Okay. In the last class, so earlier we have already discussed the number systems. For that, what I will do just cover the basics. I don't want to solve few problems in it. So I'll just cover the basics. If I am able to cover in one class, I will finish it. If not, I will take another class. That's it. Then I will move to the third topic. So at present, it's number systems. Number systems. So number systems. So earlier what we discussed is number systems, what type of numbers will be there and what are countable numbers, what are whole numbers, what are complex numbers, what are real numbers, what are integers, what exactly a negative number, what exactly a positive number. All these we have discussed. Yes or no? So apart from that, what we will discuss at present is just what exactly a complex number, what exactly a natural number, what exactly the numbers which are rational numbers, which are irrational numbers. So all those we will discuss. In complex numbers, there are two types. So one is real numbers and the other is imaginary numbers. Imaginary numbers are the numbers which we cannot write. Those are just imaginary numbers. Those are not in the real world. It is not present in a real world, but it is our imagination. Because what is I is equals to root of minus 1. So under root there is a no negative. So this is very simple. Any number of a square is always I will get a positive number because it's my imagination. So I value is I square is nothing but minus 1, which is not possible. So this is imaginary number. We are going to relate it about the imaginary numbers. We deal about real numbers. So how many types of real numbers are there? So real numbers are subdivided into again rational numbers and irrational numbers. So coming to the rational numbers of the form p by q. So all decimal forms or else decimal forms. Again decimal forms can be there are subdivision is there, right? So the real rational numbers are the rational numbers, the numbers which we can able to write in a form of p by q, then it is a rational number. What about irrational number? Irrational numbers are the numbers which we cannot write p by q and not terminating and non-repeating decimal forms. So those are again it's a decimal form, but there are few decimal points which we cannot make it in short, but it continuously the number is extending again and again and again. So it is not fixed, it is repetitive. So those type of numbers will be irrational numbers. So one is a fraction form, the other is a decimal form. Fraction form written in a p by q. There are other fraction forms which we cannot write in a fraction form, and the numbers which we can write in a decimal form, yes, can be written in a p by q form. So those decimal points can be considered as rational numbers, but there are few decimal points which are repetitive in nature that cannot be a rational numbers. Those are irrational numbers. We will move further. Subdivision again. So the p by q form is actually, so p by q, p and q are integers where q is not equals to 0. This is very simple. If the denominator is not equals to 0, then only we can find a value. If it is a 0, generally a number 2 divided by 1. 1 is, what is the activity of 1? 1 should divide 2. And 5 divided by 2. What is the activity of this denominator 2? 2 should divide that 5. So the number which is there in a denominator should divide the numerator. That is the general activity of a denominator value. So if I write 0, what will happen? 0 will try to divide the numerator. 0 will try to divide the numerator, which is very tough job. The reason is, I know 2 table, I know 1 table, I know 5 table, I know all numbers tables. All number, any number what is a multiple? Again, there is a concept called multiple should be there. So generally 0 division, if it is in denominator, if it is 0 is in the denominator, you can learn like 0 is there, then it is not defined. What I am telling, I am just making you a little clear. The reason is, what exactly a multiple? What is the activity of a multiple? One table, 1 time 1, 1 2 time 2. So that you know, 1 3 time is 3. Just like that, 2 1 time 2, 2 2 time 4, 2 3 time 6. Right? So like that, the number, next number is there. So like that, 2, 3, 4, any multiplication table, it is going to increase number by number. Yes or no? Do you agree with me? Yes or no? Yes or no? So you should agree, right? So that should be multiplied, right? So the number is always increasing if it is in multiplication table. Yes or no? So what about 0? In 0 table, is that possible? In 0 table, 0 1 time, again 0, 0 2 time, again 0, 0 3 time, again 0. So as much as I will try to divide, I will try to multiply the same 0, I will get the result as 0 only. But my expectation is it has to increase. But concept of multiplication is continuous addition. I forget about 0, but I will try to depend on multiplication, which is very tough job. So the logic is illogical one. I will be in infinite my loop. So I am inside my thought, so I cannot come out of it. So that is the reason, if a denominator consists of 0, that is undefined. So that is the reason P by Q should be, P and Q are integers where Q should not be 0. 5 by 8, minus 5 by 8, minus 2 by 3, whatever it may be. Yes or no? If you agree, type A in the comment box. If you agree, type A in the comment box. I am just waiting. Priya? Yeah, good. Right. So just like that, here 3, 0, minus 4, etc. Because 3 and 0 and minus 4 can be written 3 by 1, all integers. All integers can be written in a P by Q form. Right? So all those P by Q, that's what we are worried about. P by Q form. We are able to write, right? So all these values can be a P by Q form. What about this? All integers I can write in a form of P by Q. Yes or no? Reason is, any integer, if it is 2, take 2, 2 by 1 I can write. Take 2, the same, 4 by 2 I can write. Take 2, 6 by 3 I can write. Take 2 again, 8 by 4 I can write. Take 2 again, 10 by 5. Take 2 again, 12 by 6. So I am just making n number of forms of only 2. Yes or no? So like that, I just explained only about 2. What about other numbers? I can write. Yes or no? So all those integers, again positive or negative, I can write in a form of P by Q. All comes under only P by Q form. What about decimal forms? Decimal forms are terminating decimals and non-terminating decimals. So terminating means it is fixed. Non-terminating means completely again and again it will come, just like 1 by 7. 1 by 7. It won't come. So these are integers. Minus 1 and positive numbers and negative numbers are there, right? P by Q form. That is again negative and positive whole numbers. All whole numbers. Whole numbers, if I take 0, other than that all positive numbers. Yes or no? So other than that, 0 is a different, all other positive integers. So all negative, all 0, 1 0 and all positive numbers, all are considered, that can be considered as P by Q form. I can write. Yes or no? That's already discussed, right? So again, whole numbers, right? What about whole numbers? Whole numbers are subdivided into 0 and positive. What about positive numbers? Positive numbers are again subdivided into 2 parts actually. Actually 2 parts. That is, one is prime, the other is non-prime. Yes or no? But what happened? What is the definition of prime? Prime is depending on factors. Earlier what we depend on multiples. But at present what we will depend on factors. What exactly a factor is? Factor is a number which can divide a number. So 4 is a number. So by 1, by 2, by 4, I can divide the number 4. So this is the factor. This is the factor. So by 4 and
1, 2, 4. By all these numbers I can divide. So to divide, the number which can divide is a factor. Then now my point here is, how many factors are there for a prime number? 2 factors. If it is more than 2, what will happen? It's a composite. What about 1? 1 is neither prime nor composite. That's why they are looking as 3, but in reality it's only 2. Right? So moving to the next. All these numbers 5.41414141, that is repetitive. That is equal to 5.41 bar. So it is repeated continuously, it will occur again and again. Non-terminating repetitive decimals, right? So I can write 5.41 bar. So just like that, 238383838, it is again repeating. Yes or no? So is this a composite number? Priya, is it a composite number? What about you? Is this a composite number? What is a composite number? Composite numbers are the numbers, it should be an integer first. Yes or no? And what about this is a decimal point? How can it be a composite number? Yes or no? It's a decimal point. Yes or no? కింది నెంబరే తీసుకుందాం 5 పాయింట్, దాని కిందనే తీసుకుందాం 0.238, అన్ని పాయింట్లే ఇవి. ఎస్ ఆర్ నో ప్రియా? దీస్ ఆర్ నాట్ కాంపోజిట్ నంబర్స్. These are not composite numbers. Composite numbers are the numbers, you forget, positive integers. Integers లో నుంచి వచ్చింది ప్రైమ్ నంబర్స్ అండ్ కాంపోజిట్ నంబర్స్. ప్రైమ్ నంబర్స్ కాంపోజిట్ కౌంట్ చేస్తాం 1, 2, 3 అని. హౌ మెనీ ఫ్యాన్స్ అంటే 1.5, 1.5 ఫ్యాన్ ఉంది సార్ అని చెప్తారా? విచ్ ఇస్ నాట్ పాసిబుల్. ఎస్ సార్ నో? విల్ కౌంట్. ఎన్ని చైర్స్ ఉన్నాయంటే సార్ 4.125 చైర్ ఉంది సార్ అంటే సగమే కూర్చుంటారా వచ్చి? విచ్ ఇస్ నాట్ పాసిబుల్. We should not count like that. సో కౌంటబుల్ నంబర్స్ ఆర్ న్యాచురల్ నంబర్స్. ఎస్ ఆర్ నో? సో దాంట్లోనే ఉంటాయి కాంపోజిట్ నంబర్స్ అండ్ యాజ్ వెల్ యాజ్ పాజిటివ్ అండ్ ప్రైమ్ నంబర్స్. అంతేకాని దీంట్లో నంబర్స్లో ఈ నంబర్స్లో ఉండవు. దీస్ ఆర్ డెసిమల్ పాయింట్స్. ఓకే, ఇఫ్ యూ అగ్రీ టైప్ ఏ ఇన్ ద కామెంట్ బాక్స్. If you agree, type A in the comment box. If you agree, type A in the comment box. Yeah, done. So moving ahead. So what about the numbers here? So irrational numbers. So rational numbers are the numbers which are in a form of p by q, and rational numbers are the numbers which are there in a decimal form but it is fixed. And now it is irrational numbers which we cannot write in a form of p by q. And there are p by q, but what about this? So at least one p and q is not an integer, that is 5 by 4.2. That is not an integer. Okay, and root 2, that is we cannot write in a p by q form. And p and q should be an integers, right? Then only it's a p by q form. So this is not a p by q form, actual p by q form. So that is the reason this is not a rational number, it's an irrational number. And what about this? Non-terminating, again it's a continuously repeating, so that is also irrational number. Yes or no? Is that clear? If you are clear, CLR in the comment box. If you are clear, CLR in the comment box. So moving to the next. So everything, the complex numbers are subdivided into two, real numbers and imaginary numbers. The real numbers are subdivided into two, rational numbers and irrational numbers. And rational numbers again subdivided into two. One is p by q form, which are able to write, and the other is a decimal point. Again, the rational numbers, the p by q form again can be integers or negative integers or positive integers other than a 0. So I can consider in a 3 ways, or the whole numbers as zeros and a positive number, and the positive numbers are again subdivided into 3. One is 0, the one is 1, the other is prime numbers, the other is composite numbers. And what about the irrational numbers? Again these are two, one is p by q form which is repetitive, and p by q form which is again not a perfect form of a p by q. Then root 2, root 3 which is not a perfect square, under root not a perfect square, under cube root not a perfect cube. So all these are considered to be irrational numbers. So plain and simple, if you are able to write in a p by q, then rational. If you are unable to write, it's an irrational. That's it. So coming to the next concept, this is number line, this is just a notation. So n is a natural number, z. In few exams only this will be asked. So anyhow this is shared to you, you can go through that. Okay, and here what is even integer? Even integer is the number which able to divide by 2, that's it. So going to the next, what is odd integer? Unable to divide by 2, yes or no? Right. So the form is important, 2n minus 1, the form is important, 2n. This is even number form and this is odd number form. Okay, because if I place n value as 1, what will happen? So 2 times 1 is 2, 2 minus 1 is 1, right? This is 1. And next, so properties of positive and negative values. So what exactly this? If n is a natural number, n is a positive natural number, a will be definitely a positive number because this is a power. So positive number, whole power, natural number, any number. So if you are multiplying, then I will get a positive number. Even number, whole to the power of even positive number, definitely a positive number. Yes or no? So this is quite common, right? 1 second. Okay, so this is what I'll get the number, right? So negative number ichesam, negative number minus 1 whole to the power of square. Will I get a number positive or negative? Positive. That's what here. Even number it's a positive, odd number it's a negative, that's it. Okay, moving to the next. So what about a p by q forms? We already discussed it. So if it is a repetitive, we should use bar. If it is not, we'll remove bar. How we can convert the bar values, decimal bar values? How we will do? We will check. Yeah, this is there. So 2.46102 bar. So bar is there for 46102. How can I convert this? So I should write all the digits, and I should won't consider the decimal point as well as the bar. So I should write all the digits. So I should write, and later other than the bar I should write and I should subtract. I should subtract if bar is there. If bar is not there, no, not required. This procedure is not even required. So other than bar I should subtract, that is 2. Yes or no? So that is 2. I will use that. And what about the bar? How many bars are there? So 4, 6, 1, 0, 2. How many, for how many digits? For how many digits? It's bar 5. So for 5 I should use 5 nines. That's it. So by this I can make it. So it's a just 246,100 whole divided by 99999. If suppose the value is 2.46102, 02, for 02 only there is a bar. So let me know the answer from your end. I should write all the digits first, yes or no? So let me know the digits first. 2. Next, what should I write? 46102 minus. So in that place what I should write? Other than the bar, right? Yes or no? So other than the bar, this one, 2461 whole divided by, how many bars digits are present? Only 2. So first I should write 9 and 9. What is the reason? The reason is based on bars, based on digits under bar, I should write the 9. What about other zeros? So how many are left over other than bar? There are 3 digits left over after the decimal point. So I should write 3 zeros. So based on 3, I am writing 3 zeros. Based on these 2, I am writing these 2 9s. That's it. Very, very simple. Yes, Mamata. Yes, very good. Right? So shall we move next? So this is what a 0.1673206. So if it is there, P by Q form of a rational number, P by Q, same number, same example, and a different number, that's it. Can I move to the next? Okay, same, only 5. So other than that, I will write here, and other than that, only 1 9 is there. Reason is, bar is only for 1 digit. So very simple example. So the division. What is the division? I will take one number. So 4 how many times? 275 is divisible by 4. 4 how many times 275? If I know, if I calculate, if I am able to calculate, if I am good at my calculation, I will do it directly. 4 68 times. 68 double is how much? No, 136. 136 double is 136 double is I am just waiting. 272. So 4 into 275, 68 times 272. Remainder is 3. I can write. If I am not that much good at, I am not that much expert, and my RAM size is very small, then I will calculate like 4 6 time, 4 8 time separately. So if I do that, so 4 6 time 24 and 3, and again I will get a 5, and again 32 minus 3. This is what, by which I am dividing, that is called a divisor. By which I am able to divide, that is what a quotient. What I left, it's a remainder. What I am doing, on which I am doing all these calculations, it's a dividend. So that's it, it's a dividend. So here 275 is dividend, 4 is a divisor, 68 is a quotient, and the remainder is 3. That's it. So divisor, there is a difference. Divisor is the activity by which I will divide, that is called a divisor. On which I am doing these calculations, that is what a dividend. By which I am able to divide, that is what the quotient. What I am left with, that left value, that left number is nothing but my remainder. So how can I make it? Don't try to by heart this formula. Formula is not that much required. So actually multiply these two, because I am dividing. The opposite reaction for the division is multiplication. Opposite reaction for the subtraction is the addition. So multiply 4 times 68, because you can do that. So 68 4 times, 68 double is 136. Double is again how much? So 272. So 272, because double is nothing but 4 times, right? So double is 4 times, and the difference is very simple. The difference is nothing but a remainder. That remainder value here is a 3. So that remainder is a remainder. That remainder is, by subtracting, I am getting. So that have to be added. So this is not a formula. Don't by heart it as a formula. Just have a common sense. By which I am dividing, so I should multiply. On which I am dividing, I am multiplying, so I should multiply. Because I am dividing, I should multiply. By which, what is I am getting, so that should be added. If I do that, I will get my dividend. That's it. Very, very, very simple. Yes or no, Johar? Are you clear? Johar, are you clear? Yes, very good. So moving to the next. So tests of divisibility, right? So divisibility rules will be discussed. What is the divisibility rule for 2? Divisibility rule for 2, please, because this is already known to you. Yes, last digit should be divisible by 2. So the content definitely it will be a theoretical explanation, but what I am telling is very important. So the last unit digit have to be divisible by 2, then only the complete number can be divisible by 3. That's it, very simple funda. And what about the divisibility rule for 3? What about rule for 3? Sum of all digits should be divisible by 3. That's it. So 9, 3, 4, 5, 6, 7, 8, 9, 4, 5, 6, 7. Is this divisible by 3? Come on, type your answer. And what about you? So 9, 3, 4, 5, 6, 7, 8, 9, 4, 5, 6, 7. Is this divisible by 2? Sorry, is this divisible by 3? Come on, you should be very faster. You should be very faster. Yes, very good. So why you are taking that much time? Very less time when compared to others. Very simple. Remove 9, remove 3, remove 4, 5, remove 6, remove 9, remove 4, 5, remove 6. 7 plus 7 is 14 plus 8 is. 14 plus 8 is how much? Or else 7 plus 8 is 15. That is divisible by 3. 7 is there. 7 cannot be divisible by 3. So the number cannot be divisible by 3. Not divisible by 3. No need for the rules. Don't follow the books. Please understand the books. Okay, you should not be a follower, you should create your own rules. Any subject. Is that clear? Yes or no? Yes or no? So some of the rules, if you go on finding it, what you will do, you will add everything. Right? If you add everything, it will take a lot of effort and it will take a lot of time. Yes or no? So you should reduce your effort. But that should be planned. You should be very lazy. I feel lazy. I feel my students should be lazy. And I am happy with my students if they are very lazy. Reason being behind it is they always try to find only shortcuts. Right? Okay. Moving to the next. What about the divisibility rule for, what about this? 9, 4, 8, 6, 5, 3. Is this divisible by 3? Priya, Mamta. What about you? Not divisible by 3. So 9 is divisible, 6 is divisible, 3 is divisible. 8 plus 4 is 12, that is divisible. 5 is not divisible by 3. So the number cannot be divisible by 3. Excellent, Mamata. Very good. So what about the divisibility rule for 4? Last 2 digits, because this is 2 square. Don't forget. 4 is a 2 square value, 8 is a 2 cube value, 16 is a 2 power 4 value. So 2 power 1 is the last unit digit have to be divisible by 2, and the last 2 digits are divisible by 4, and the last 3 digits is divisible by 8, and the last 4 digits are divisible by 16. So that is the funda based on the divisibility rules. Is that clear? So explanation will be there. You should be careful. What about 5? According to books, you will be realized and you know that last digit is a 0 and 5. That will be there in school books. So is that so? So you should think beyond the books. So it is the best approach is take the last digit. If it is divisible by 5, then it's okay. Because it's a 0, 0 is divisible by 5, then the number is divisible by 5. Yes or no? It's enough. No need to think it's a 0 and 5. The reason behind it is, if you are able to think without any logic, what will happen? You should able to learn 0 and 5 for the 5, and 25 you should able to learn 25, 75 and 0, 0, and for the 75 you should able to by heart all other numbers. If not, if you are depending on 5 logic, if you are logically strong, then 25 you will find for last 2 digits. You won't find for 25, 50, 75, 100 ఏది ఉంది అని వెతకం. లాజికల్గా ఆలోచించండి, లాజికల్గానే ఆలోచిస్తారు. ఎస్ ఆర్ నో? ఎస్ ఆర్ నో? వాట్ అబౌట్ 6? 2 and 3. Why I am depending on 2 and 3? I should able to have another different rule. ఏదైనా డిఫరెంట్ రూల్ ఉంటే బాగుంటుంది కదా. ఎస్? Because 2 a prime number, 3 another prime number, 5 another prime number. Yes, 3 is a prime number, so 9 is implemented by 3. 9 is not a prime number, but 9 is just because of 3, the rule is applied to 9. Because of 2, the rule is applied to 4. Because of 2, the rule is applied to 8. Because of the same 2, rule is applied to 16. Because of 5, the rule is applied to 25. Okay, because of 7, the rule is applied to 14. But what about the rule for 17? Rule for 7. It's very hard. Okay, we'll go through, don't worry. So rule for 6 is it have 2 and 3. If you agree, type A in the comment box. If you agree, type A in the comment box. Rule for 6 should depend on 2 and 3. Very good. Moving to the next. So divisibility rule for 7. So please go through that. A number divisible by 7 if and only if the difference of the numbers thousands and remaining of the given numbers should be divisible by 7. So 4, 7, 3, 3, 1, 2 is a number divisible by 7 because the difference of 4, 7, 3, that is thousands. 4, 7, 3 thousands is one number and 3, 1, 2 is another number. So I should be able to subtract these two. Then I should take 161. Then I should take divided by 7. If that is divisible, then this can be divisible. Or else the other number, the other logic is also there. So 4, 7, 3, 3, 1, 2. So remove 2, make a double and subtract from this. You will get another number. In that last digit, again double it and subtract. Again you will get another number. Again take last digit, double and subtract. Do like this until you will get one digit and or two digits. And later try to solve by 7. If that is divisible, that bigger number will be divisible. Is that a joke? So it will take time, right? So don't depend on the rule. Please solve directly by 7. Is that clear? Right. Moving to the next. So 8 is already known because it's just a 2 cube. Last 3 digits. It's enough. So what about 9? 9 is again depending on 3. Yes. What about 10? 10 has a rule. Rule is just depend on last digit. If the last digit is 0, it is fixed. There is no other alternate. If the last digit is 0, then that is divisible by 10. What is 10 square? 100. 100 has how many zeros? So if the last 2 digits are zeros, then it is divisible by 100. What about 1000? 1000 is 10 cube. Last 3 digits are zeros, 3 zeros, then it is divisible by 1000. So the logic is implemented like that. Is that clear? Yes or no? Right. Moving to the next. This is very interesting, quite interesting. 11 is also a prime number, another prime number. So the rule is already there. So the rule here is very, very simple. So here what is the number? So it is very bigger number. I will take another number. 1342 is one number. 1342 is a number. Is this divisible by 11? So what I will do, I will take the odd places and the other even places, alternate places. So the addition here is 5, the addition here is 5, the subtracting these two, I will get 0. That 0 is divisible by 11. Yes or no? That 0 is divisible by 11. So this number is divisible by 11, I can say. That means the differences between the sum of the odd places and even places is divisible by 11, then the number can be divisible by 11. If you are clear, CLR in the comment box. If you are clear, CLR in the comment box. If you are clear, CLR in the comment box. Okay, good. So like that, here 29435417 is a number. So 2, 7 and 4 and 4 and 3 and 9. 9 plus 3 plus 4 plus 7. How much? 9 plus 3, 12 plus 4, 16 plus 7. How much? 23. And what about this? 2 plus 4, 4 plus 5, 5 plus 1. 11. So 23 minus 11 is 2 plus 4, 6, 6 plus 5, 11 plus 1, 12. So 23 minus 12 is 11. Is that divisible?
By 11? Yes, sir.
Yes, that is divisible. So this is divisible by 11. That's it. So are you clear? So rule is very simple. Difference should be divisible by 11. Okay? So if the difference is 0, then again divisible by 11. If it is difference is 11, then again it divisible by 11. If the difference is 22, generally 22 difference, it is very rarely come. The number should be very huge. More number of digits. Generally it won't come in the examination. Right? Coming to the 12. 12, is it a prime number? No. This is a composite number. It should depend on other co-primes. Co-primes. Factors, definitely, but co-primes. If not co-primes, then I should depend on 2 and 6, which is not possible. Which is not possible. So this is wrong. Wrong assumption. So you should able to tell it's co-primes. Right? HCF should be 1. Then only it's a co-prime. Yes, Priya, are you clear? As you said no, I am just asking. Okay, great. So this is how we are doing, right? So coming to the other. So take one example here. So value 7 star 5 4 6 3. Is this divisible by 11? This is divisible by 11. So what we require is the least number should be placed in a place of star, right? So first, what you will do, what is the logic? What is the logic of divisibility? What is the divisibility rule for 9? Sum of all digits should be divisible by 9. So 7 plus 5 plus 4 plus 6 plus 2, what is the value? 24. Is 24 divisible by 9? How much short? So answer is over. 3. So 7, 3, 5, 4, 6, 2, answer 3. Answer over. Okay? So take another number. 48332 star 18. Is that also divisible? No, this is divisible by, this should be divisible by 11. So what I should do? 8 plus star plus 3 plus 4 and 8 plus 2 plus 1. 8 plus 2 plus 1 is 11, right? 11 plus 4 plus 3 is 7. 7 plus 8 is 15. 15. If I subtract 15 minus 11 is 4. Yes or no? 4 should be, what should be added to get 11? What should be added to get 11?
7.
That's it. So 7. Finally, answer is 7. If it is 4, 8, 3, 2, 7, 1, 8, answer over. This is explanation. You can check later, right? So again, prime numbers. What is a prime number?
A number which has 2 factors.
Only 2 factors, then it's a prime number.
Itself.
Yes, very good. So how many prime numbers are there present in less than 50? Reshma?
15.
50 lopu. Only 15. Okay? So the numbers are 2, 3, 5, 7. How many prime numbers till now? Less than 10. There are 4 prime numbers. So, ఒక 10 numbers లో 10 నంబర్లలో వరుసగా ఉన్న 10 నంబర్లలో 4 ప్రైమ్ నెంబర్స్ ఉన్నది ఇది ఒక్కటే ఇన్ ద వరల్డ్ ప్రపంచంలో 4 ప్రైమ్ నెంబర్స్ ఉన్న సెట్ ఇది ఒక్కటే దెర్ ఇస్ నో అదర్ సెట్ అనదర్ 10 ఎక్కడన్నా చూపియాలి కదా సార్ 11 13 17 ఉంది కదా అని సైలెంట్గా ఉన్నారు 11 13 17 19 సార్ దాని పరిస్థితి ఏందని అడగాలి కదా ఓకే సో స్టార్టింగ్లో ఉన్న ఈ 10కి మాత్రమే 4 వస్తాయి దాని తర్వాత రావు ఓకేనా ఇంకా రాను 3 వస్తాయి దాని తర్వాత ఇంకా రేర్ అయిపోతుంది మళ్ళీ 2నే వస్తాయి దాని తర్వాత ఇంకా రేర్ అవుతుంది అప్పుడప్పుడు ఒకటి కనపడుతుంది ఓకే యాజ్ లాంగ్ యాజ్ ద నెంబర్ ఈజ్ గోయింగ్ టు ఇంక్రీజ్ you will find very less prime numbers will present in few sets. right? So numbers 2 3 5 7 and 11 కి వెళ్ళిపోయాం, right? 2 3 5 7 4 11 13 17 19 another 4 4 plus 4 8 అక్కడ పడేయండి. 20 నుంచి కౌంట్ చేసుకుందాం. 20 తర్వాత నంబర్ 23 29. yes or no? 23 and 29. is there any other number ఈ సెట్లో లేదు. 30s లో చెప్పండి. 31 37. సో అనదర్ 4 రావాలంటే 20 నెంబర్స్ కావాలి. ఓకే, నెక్స్ట్ 41 43 47. సో హౌ మెనీ? 7 7 plus 8 15. సో 50 వరకు 15 ఉంటాయి. నెక్స్ట్ 50 తర్వాత హౌ మెనీ? ఓకే, 50 తర్వాత 51. ఈజ్ 51 ఏ ప్రైమ్ నెంబర్? 53 ఏ ప్రైమ్ నెంబర్? yes. 55 ఏ ప్రైమ్ నెంబర్? no. 57 ఏ ప్రైమ్ నెంబర్? no. 58 అస్సలు కాదు. 59 yes. 53 and 59 2. okay, now 60s లో 61 67. is there any other number? no. అక్కడికి 4 అయిపోయాయి, రైట్? 70s లో ఎన్ని ఉన్నాయి? 71 73 79. 77 is 11 divisible, right? yes or no? yes. 80s లో ఎన్ని ఉన్నాయి ప్రియా? 81 పోదు, 9 9s. సో 83 yes. 87 3తో పోతుంది, 3 times 29. ఓకే, సో 89, రైట్? ఇప్పటికి ఎన్ని అయ్యాయి? మర్చిపోయినాం సార్. 15 50 లోపల అయిపోయినాయి. 50 తర్వాత ఎన్నైనా అనేది కౌంట్ చేస్తూ ఎన్నైనా 90 వరకే కౌంట్ చేసింది. ఎస్, 9 అయ్యాయా? 90స్లో ఏముంది ఒకటి చెప్పండి. 97 అంతేనా? దట్స్ ఇట్. సో టోటల్ ఎన్ని అయిపోయాయి? 100 వరకు ఎన్ని ఉన్నాయంటే 25 ఉన్నాయి. ఎస్ ఆర్ నో? సో ఆల్ దీస్ నంబర్స్ ఆర్ ప్రైమ్ నంబర్స్. చెప్పుకున్నాం. ద వన్ అండ్ ఓన్లీ వన్ ఈవెన్ ప్రైమ్ ఇస్ 2. ద వన్ అండ్ ఓన్లీ 24 కాదు నాన్న, 25 అయ్యాయి. 25 ప్రైమ్ నంబర్స్. ఓకే, సో ఆల్ దీస్ ప్రైమ్ నంబర్స్, దీంట్లో ఉన్న ప్రైమ్ నెంబర్స్ అన్నిట్లో కూడా 2 ఈజ్ ద వన్ అండ్ ఓన్లీ వన్ ఈవెన్ ప్రైమ్ నెంబర్. ఓకే, ద లీస్ట్ ప్రైమ్ ఈజ్ 2. ద గ్రేటెస్ట్ ఈవెన్ ప్రైమ్ ఈజ్ 2 ఓన్లీ. ఓకే, సో సింగిల్ డిజిట్లో ఉన్న స్మాలెస్ట్ ప్రైమ్ నెంబర్ 2 ఓన్లీ. ఓకే, ఈవెన్ నెంబర్స్లో ఉన్న ఏకైక ప్రైమ్ 2 ఓన్లీ. సో దెన్ ద కాన్సెప్ట్ కాల్డ్ co-primes. Okay, right, we'll take a break now. So we'll stop today, we'll continue this tomorrow again. So tomorrow we will finish it, right? Okay, bye bye.